Okay, so for our Chapter 6 free response, we are going to jump into it. Our first question is a rate in, rate out question. And so we're given a rate in, and it's very obvious, G of t, that's a rate in. We have to kind of look, and this 100 tons per hour is the rate out. Now, if you're not sure what the 100 tons per hour is, what you want to kind of look at is look at the units. So the rate in was tons per hour. When you see 100 tons per hour, that also has to be a rate, and that's, in this case, the rate out. Okay, they also give us the initial value at time 0. The plant has 500 tons of unprocessed gravel. So part A says find G prime of 5, just G and G prime of 5. So on our calculator, nice and easy. To explain this, we want to look at what was G. G was the rate at which unprocessed gravel arrives. So we're going to say that G prime will become the rate of the rate. Right? So we're going to say the rate of unprocessed gravel that arrives at the plant. And for our units, we're always going to just take a derivative. We add on a per time. So in tons per hour squared. And I just said is negative 24.5 at t equals 5 hours. Okay, B says find the total amount of unprocessed gravel just that arrives. That's very important. Just that arrives. Not the amount at the end of the day, but just that arrived. So you want to pick out those keywords. If it says find the total amount at a certain time, then that would be the whole, starting point plus the integral of the rate in minus the integral of the rate out. When they only tell you the amount that arrived or the amount that went in or the amount that went out, in this case, right, we don't, let's change our color here. We don't use the starting value. And we don't need both the rate in and the rate out, right? We just take the integral of the arriving. So in this case, that's just going to be the integral from 0 to 8 of g of t, and we get 825.511. Now C says, is the total amount increasing or decreasing? So we want to take the total amount, we want to take the derivative of that. Well, the derivative of that is just the total rate. And our total rate will be the rate in minus the rate out. Oops. So our rate in minus our rate out is g of t minus 100. So we're going to take g of t minus 100, and sometimes we would set it equal to 0, but this time they're just saying, is it increasing or decreasing at 5? So we're just going to plug in 5. So you're just going to do g of 5 minus 100. When you do that in your calculator, right, you get negative 1.85 less than 0. So that means that the rate of the amount of unprocessed gravel is decreasing because the overall rate is negative. Make sure you write out a sentence like that. And then D asks, what is the maximum amount of unprocessed gravel? And so if we ever want the maximum amount, again, we're going to take the derivative of the amount because that's what we're trying to maximize. So the derivative of the amount is that total rate. So we're going to set the total rate to 0, which is g of t minus 100 equals 0. This is worth 1 to 2 points. Make sure you write that down. Even if you don't do anything else, write that down. You just got 1 to 2 points. So whenever you see that maximum, just take your derivative, set it equal to 0. In a rate question, take your rate in minus your rate out, set it equal to 0. So we get t equals 4.92 on our calculator. When I did it on the solve button, it didn't really work out. I got something nasty. So if you ever get something nasty like that, then just do it on the calculator. So I just graphed this, on my calculator, g of t minus 100. Right, it's kind of hard to see because that word label's in the way, but that's, g of t and then there's minus 100. That's the graph. And then I changed my zoom settings to be from 0 to 8. It was kind of zoomed in, so I went out to 0 to 20, and I figured it doesn't really matter because I don't have any other zeros. Right, this is above the axis, that's below the axis. There aren't any other zeros. So I did menu, analyze graph, and then zeros. I went to the left, to the right, and that gave me that 0. So this is what I wrote in for that line, right? Now that I have that, I got my 1 to 2 points there. Then we can try to go in and actually find the answers for each of those. So we make our table for 0, 4.98, my critical point, and 8. And what we are going to do is 0 starts off at 500. And for the other points, we can kind of use this general formula. The amount at B is equal to the amount at A plus the integral from A to B of the rate in minus integral from A to B of the rate out. Now, I wrote this with a T. You don't have to write this with a T. You could have written it with a B. You could have written it with literally 4.92. You could have written it however you want to write it, but make sure you have something written to that extent. like I said, it could be with the t, it could be with 4.9, but you need to show the grader that you know how you got those answers. Okay, so this is how I type them into my calculator, right? And then when we're looking at this, the maximum would have been 635, and so we just kind of write out a sentence like that. The max amount is 635 at time 4.9. Okay, next up we have a velocity question, and they give us a formula for velocity. They tell us that we know that the position at 0 is 10. A says find all the values where the speed of the particle is 2. This is actually a repeat question. We just take the absolute value of v of t, set it equal to 2. On the calculator, I use the solve button, and I get these two values. On B, we want to then get to a position formula. So we only were given one position. So we're not going to do FTC. Oh, no, this is my fault. We are given two positions. But first, this is write an equation for the position. And so this is a little bit weird. But, you could have actually done it. But this is kind of weird. And it says write an expression involving an integral. That's the key part. Involving an integral. So there should be an integral in your answer. And so this is s of t equals s of 0 plus the integral from 0 to 10. S of 0 is 10. So this is the expression involving the integral, right? It's 10 plus the integral from 0 to t of v of t, right? That's FTC. So they're basically asking you to do FTC. So make sure you kind of read this and get comfortable. If it says write an expression or write an equation involving an integral, right? That's probably that FTC, the f of b equals f of a plus the integral. Okay, then they said use it to find 5, so we plug in 5. S of 5 equals 10 plus the integral from 0 to 5 of v of t. We just do that over here on our calculator, and we get negative 9.2. C, find all times when the particle changes direction. We need to make sure that we key in particle changing directions to when v changes signs. So we need to set v equal to 0 and do a number line analysis. Okay, or we can graph it, right? We have a graphing calculator, even easier, like graph it. So I set v of t equal to 0. On my calculator, I use the solve button from 0 to 5. I got 2 answers. Make sure you write all of this in. That's probably a point, maybe 2 points. And you can do a number line analysis. And to get the negatives and the positives, I just used a graph. It was easy. So we're below the axis, above the axis, below the axis, right? This is the graph of v. You could have also gotten the zeros without using the solve button. If you didn't want to use the solve button, you could have gotten them here on the graph. Okay. Now we do need to write the statement because they asked us to explain or to justify. So the particle changes signs. This is my fault. The particle changes directions. That should have said directions. At time 0.5 and 3.1 because v of t changes signs at these values. Okay, and then our last one is the speed increasing or decreasing? Anytime we see speed increasing, decreasing, we do v of 4 and a of 4. So v of 4 we just plug in, a of 4 we do the derivative and plug it in. They're both negative, so the speed is increasing because v of t and a of t are both less than 0. You could say same signs if you want to add that on. All right, next up we have hot water. And these ones I'm going to do with you guys just to kind of get that experience because they are kind of difficult. Okay, so we have hot water. We're given this table. And it says the amount of coffee in the cup is given by C, where T is in minutes. And so C is not the rate, it's already the amount. So we want to be careful. C is already the amount. Use the table to approximate C of 3.5 and show your computations and indicate units. So right, anytime we're trying to approximate a derivative, we need to remember that that matches up with f of b minus f of a over b minus a. So you can do c of 4 minus c of 3, right? Because 3.5 would be in between 3 and 4. Over 4 minus 3. C of 4 is 12.8 minus 11.2 all over 1. Okay, and this was, I didn't write calculator on here. This was a non-calculator question. So, we can I would just leave my answer like that. I would just leave my answer like that. And then, my units are ounces per minute because we're doing a derivative. Now, if you want to go in and subtract, you can, right? 12.8 minus 11.2 isn't hard. It's 1.6. But if it were me, non-calculator, I just leave my answer there. All right, B says, is there a time between 2 and 4, where C prime of t equals 2. When I see that is there, I'm thinking MVT, I'm thinking IVT, I'm thinking rolls. When I see C prime, now I'm thinking MVT or rolls, and equal to 2, I'm thinking MVT. So immediately I'm thinking MVT. The first thing I want to do is make sure that I state that rolls can apply. So I'm going to say C prime is differentiable. That means C is continuous. And that means that MVT applies. Okay, so now I want to do MVT, which would basically be saying, C prime of t, right, could be equal to, now we're going to do C of our endpoint, so C of 4 minus C of 2 over 4 minus 2. And then we just go on our table, so I'm going to write C prime of t equals, on our table, C of 4 was 12.8, minus C of 2 is 8.8, over 2. That's going to give me C prime of t equals 12 minus 8, right, the 0.8's cancel, is 4. 4 over 2 is 2. So we can say kind of therefore, by MVT, there is a value t for 2 less than t less than 4. I'm just kind of copying exactly what the question said, for which C prime of t is equal to 2. Okay, it's important to write that sentence, but also do the work. Okay, C says use a midpoint formula, a midpoint Riemann sum, with 3 subintervals to approximate the value of 1/6 the integral from 0 to 6 of C of t, and then to explain what that means. So first, let's do that, and then we'll state what it means. So the 1/6, you want to make sure that you just put like a big parentheses, right? Because we're doing the midpoint formula and then multiplying by 1/6. So 3 subintervals. This is distance of 2, distance of 2, distance of 2, and our middle would be 5.3. The middle between 2 and 4 would be 11.2, right? That's to here. And then I kind of drew those badly, right? 0 to 2, 2 to 4, and then 4 to 6. In the middle of 4 and 6 would be the 13.8. So 2 times 5.3 plus 2 times 11.2 plus 2 times 13.8. And again, you don't actually have to multiply these out. So I would literally just say that our answer is 1/6 times, now if you want to, you can, maybe just 10.6 plus 22.4 plus, that's 13 times 13 is 26, and then add on 0.8 twice would be 27.6 ounces. And you could just leave that. I wouldn't even bother to keep going, but if you really had to, you're going to get 1/6 times 60.6. 60 divided by 6 is 10, and 0.6 gives us 10.1 ounces. So I mean, you could have done this all the way by hand, but literally, as long as you have the word ounces, and even up here, ounces. So if we said ounces up here, I can't get that in, but literally any of these lines would give you full credit. You don't have to simplify it on the free response. Okay, but then they did say that they want to know what this means. So 1/6, the integral from 0 to 6 of C of t dt, since we have the 1/6, that's our average value. So is the average value of, and then just copy down what they told us about C. C was the amount of coffee in the cup. And then in ounces, right? We're not going to chop off anything because average value, we keep our units the same. There's also nothing to chop off. Over 0 less than or equal to t less than or equal to 6 minutes. Okay. And then finally we have D. D says the amount of coffee in the cup is modeled by b of t equals 16 minus 16 e to the negative 0.4t. And using this model, find the rate at which the amount is changing at time 5. So when we have an amount and we're going to a rate, that's a derivative. So when you start off at the rate and you go back to the amount, that's an integral, but going from amount to rate is a derivative. So d is, we have b of t equals 16 minus 16 e to the negative 0.4t. We want to find b prime of t so that we can then find b prime of 5. So derivative 16 goes away. This is going to be negative 16 e to the negative 0.4t times negative 0.4, right? That's chain rule. The derivative of e to the x is, right, e to the x times the derivative of, chain rule. So this is e to the box times the derivative of the box. So 0.4 times 16, right? 4 times 16 is 64. So this would give us b of t equals now 64, but we have a decimal, so that becomes 6.4 e to the negative 0.4t. And again, if you left it like this, that's totally fine. So that's b prime of t. So b prime of 5 then becomes 6.4, and then times e to the, now negative 0.4 times 5. 4 times 5 is 20, negative 20, move the decimal over to the negative 2. Then our units are ounces. We took a derivative per minute. So that's our answer. Now, if you had just kind of left it here, I want to just show what you could have also done, is you literally could have said b prime of 5 equals negative 16 e to the negative 0.4 times 5 times negative 0.4 ounces per minute, and you would have gotten full credit on the AP exam. You don't have to show all of your work there. You just need to plug in the numbers, right? You don't need to like simplify them. Okay, next up, this is a great question about kind of area under the curve. And so we're given this graph of f prime, and we're told where we have horizontal tangents, and then we're also given the areas under the curves, and then we're told that f of 8 equals 4. So A says find all of our values where we have maximums and minimums. This is a kind of a repeat question from a lot of the earlier chapters, right? So we would want to set f prime of x equal to 0 to get our critical points, and that's going to be at x equals 1, right? X equals 4, and then x equals 6. Okay, and they just said local minimums, right? They just said local minimums. So if we do an f prime number line analysis, and let's actually put endpoints on this. So we're going from 0 to 8, right? 1, 4, and 6. F prime is above the graph, so positive, above positive, below negative, and above positive, right? We're doing it this way because it's already the graph of f prime. So increasing, increasing, decreasing, increasing. So the only minimum is at 6. So we'd say f has a local min at x equals 6 because f prime changes from negative to positive at x equals 6, or at that point. Oops. All right, B, determine the absolute minimum. So this, we have to make sure that we do the right steps, the right process, right? And with absolute minimum, our first step is always to set f prime of x equals to 0. I know I already wrote that, but I'm just going to write it one more time. Just if the grader's looking for it, they see it. Okay, that's 1 or 2 points. Then from there, we're going to make a number line, right, with x and f of x. So I'm going to put in my endpoints and then my critical points. So they gave us that f of 8 was 4. So they actually started out with our last point. F of 8 was 4. And to get the rest of these, we're just going to kind of write FTC. So f of 0 equals f of 8 plus the integral. Now be careful about this because 8 is going to go on the bottom. The integral from 8 to 0 of f prime of x dx. I know that's weird because 8's on the bottom. You can do one of two things. You can either just take all these areas going backwards and just remember that as you work backwards, they flip. Like if it was positive 7, it becomes negative 7. Negative 3, it becomes positive 3 because we're going backwards. Positive 6 is negative 6. Positive 2 is negative 2. Or if you're like, I don't like that as endpoints, that just freaks me out, I'm not going to do well with that, then what you can do is just use our property, right? F of 8 was 4, and use our property to change the plus to be a negative, integral from 0 to 8 of f prime of x dx, and now you can go left to right. I kind of like doing that. So this is 4 minus, but we would need to, if you do it that way, you would need to put this all in parentheses. So the areas are 2 plus 6 is 8, minus 3 is 5, plus 7 is 12. So 4 minus 12 is negative 8. Okay, then you're going to do the same thing for f of 1. Now, actually, what I like to do better is right here. Now I know that f of 0 is negative 1. So to go from 0 to 1, I'm at negative 8. Negative 8, I'm just going to add on the 2. So negative 8 plus 2 is negative 6. Now I'm at negative 6, and to go from 1 to 4, I'm going to add another 6. So f of 6, we should get, oh, sorry, I'm at 4. That's my fault. Yeah, f of 4, we should get to be 0, right? So that's where I messed up. I just said it wrong. So I'm at, basically f of 0, we now know is equal to negative 8. So I need to add 2 to get this one, and add 6 more to get this one, so I'm at 0. Now at f of 4, we're at 0, right? And to get to f of 3, we're going to do the, basically 0 plus the integral, which is the area under the curve, and that's below, so we're going to subtract 3, and we're at negative 3, right? You could have done it the way I kind of did in my head, or you could have kept writing these out and kept doing those. Right, so, if we had done it that way, it would have been like f of 1 equals f of 8 plus the integral from 8 to 1 of f prime of x. And just to show you guys how to do it like the backwards way, if I was doing it the backwards way, this would have been 4 plus. So I'm starting at 8 and going backwards. So this would be negative 7, positive 3, and negative 6 until I hit 1, right? Because we're going backwards, so 4 plus negative 7 plus 3, and then plus negative 6. And so this would have been 7 and negative 7 cancel out. We get negative 6, which that's the answer we had. So that's just kind of a few different ways to look at it. Anyways, we wanted the absolute minimum. So the absolute minimum here is the negative 8. We're just going to write that out. The absolute minimum of f is negative 8 at x equals 0. Or you could even say, f of 0 equals negative 8. That works as well. All right. C asks us on what open intervals is the graph both concave down and increasing. So we're given the graph of f prime, right? We're given the graph of f prime. So we want to remember that concave down is going to be when f prime is decreasing. And then just regular decreasing, like when f is decreasing, that's going to be when f prime is negative. So we want to know basically when is f prime decreasing and negative. So we're decreasing in negative, the only time is from, that's at 4 to 5. That's only, oh wait, no, sorry, that's concave up. So we're, oh, sorry, I totally messed this up. I just can't read. On what open intervals is the graph concave down and increasing? So increasing, that's totally my fault. Increasing, right? So like basically f being concave down is when f prime is decreasing. And then f being increasing will be when f prime is positive, when it's above the axis. I don't know what the heck I was doing. So we want to find somewhere where f prime is decreasing, but it's above the axis. So it's decreasing and above the axis from 0 to 1. It's also decreasing and above the axis from 3 to 4, and nowhere else does it decrease and be above the axis. So we will say that f is concave down and increasing for 0. We can do 0 less than, or we can just do 0 to 1 union 3 to 4 because we're connecting it to f. So f prime is decreasing. That takes care of like the concave up part. And f prime is positive on these intervals. All right, and then D was a little bit weird. D gave us a new formula. They gave us a formula for G, right? And so they said on D, they said that g of x equals f of x cubed. And they told us that f of 3 is equal to negative 5 halves. And they wanted us to find the slope of the line tangent to the graph of g at x equals 3. Okay, so to find the slope, we're going to do g prime of x. This is chain rule, that's our outside. So 3 times f of x squared, we can kind of cancel that out, and times f prime of x. So to get g prime of 5/3, that's why they gave us f of 5/3, 3 times f of 3 will be negative 5 halves squared times f prime of 3, right? So negative 5 halves is negative 25 over 4. And then f prime of 3 is just our y value at 3. So because this is the graph of f prime already, so that's 4, right? 3 comma 4. So times 4. This is non-calculator. I would literally leave my answer like that. But if you want to multiply it out, the 4's cancel, we get negative 75. It's not really that hard. I'm sorry, positive 75, because this was, that should have turned positive when we squared it, right? Positive 25 over 4. So make sure that's a positive. Okay, you could have also written it like 3 times negative 5 halves squared times 4. Like that could have been an answer. This could have been an answer, or this could have been an answer. Okay. Next up, we are given another one of these basically table questions where we're going to do a Riemann sum. And so part A asks us to approximate the, and this is my fault. This should have been a calculator question. Okay, so if you were like really confused on this one should have been a calculator question. I need to add in the little designation. So anyways, this guy, right, use the data in the table to estimate w prime of 12. So A, w prime of 12 is approximately, and then we're going to have at 12, 67.9 minus 61.8 over 15 minus 9. And that will be approximately, you can just use your calculator, 1.017. Okay, and then we need units. So this would be degrees Fahrenheit per minute. Right, we're going to take the units that we had and add on a per time. Then it says, using correct units, interpret the meaning. So W was representing the temperature of water in the tub. So this means that the temperature of water in the tub is changing at a rate of 1.017 degrees Fahrenheit per minute at time equals 12 minutes. And we might want to work a rate of approximately, since we did an approximation for it. Okay, B asks us to do the integral from 0 to 20 of w prime of t. And normally when we get these integrals, we do Riemann sums. But this doesn't have a Riemann sum. It doesn't say approximate, it says evaluate. And we have w prime. Okay, this is something that we don't see a lot on the tables, but it can happen. This becomes w of 20 minus w of 0. Okay, right, because the integral from w prime becomes w, right? You could have done like w of t from 0 to 20 and plugged it in to get there, right? But that's FTC. So we're just going to go back up on the table. W of 20 is 71. W of 0 is 55. 71 minus 55, you can use your calculator, is 16. And again, they ask us to interpret that. Now, this is, because we did the integral of w prime, and we go back to w's, the units are the same as w's. So it's 16 degrees Fahrenheit. So what this is it's the amount of change of w. So this is saying, the temperature of the tub changed, right? Integrals are the change in the amount. So changed by 16 degrees Fahrenheit from 0 to 20 minutes. Okay. So that's kind of how that works. C then asks us to now do an integral with W, and since W is in the table, that is when we are going to have to do a Riemann sum. So on C, they ask us for 1/20th, the integral from 0 to 20 of W of t dt. And so we're going to say that this is approximately 1/20th. Now we need to put in a big parentheses when we do our Riemann sum, and we're doing a left Riemann sum. So that's going to be 4 times 55 plus 9 times 57.1 plus 6 times 61.8 plus 5 times 67.9. And you can type that all into your calculator, right? 4 times 55 plus 5 times 57.1 plus 6 times 61.8 plus 5 times 67.9. You plug it all into your calculator, and you will get 60.79. Okay, and the units are kind of weird. Don't even worry about the units because you're supposed to chop off a time. They didn't ask you for the units, so just kind of ignore them here. But it says, is this an over or under approximation, right? Make sure we read the whole question. So is this an overestimate or an underestimate? Oh, and the units are, this is my fault. We do need the units because it's the 1/20th, right? When we do this 1/20th integral, we always keep the units the same. So our units are going to remain at degrees Fahrenheit, right? So whenever we do an average value, this is an average value, we keep our units the same. So this is, you should recognize that as the average value formula. So if they asked you what does this represent, that represents the average temperature in the tub between 0 and 20. But they didn't ask us to explain it. They asked us, was it an over or underestimate? So we need to look up here, right? A left Riemann sum, right? If I kind of just draw increasing and decreasing. If I have an increasing, then a left Riemann sum will be under. If I have decreasing, then a left Riemann sum starting on the left will be over. So here they say a strictly increasing function. So if I've drawn an increasing graph, my left side is underneath it. So what we'll say is that something like this approximation is an underestimate for the average value, or for the average temperature, right, of the water. I'm just kind of trying to copy what they said in the question over these 20 minutes. And then we need the because, right? And we can just say because W is increasing, and we used LRAM, left Riemann sum. If you want to write it out, you can write it out, but I'm just going to put LRAM. Okay. And D asks us to find, they give us a new function. They say that now we're going to use W prime of t, and we're going to use that between times 20 and 25. And that's equal to 0.4 square root of t cosine of 0.6 t. And then they want us to find W of 25. So we can say W of 25 is equal to, now you're not going to do, right, this is like the f prime of b equals f of b, this is my fault, f of b equals f of a plus the integral from a to b of f prime of x dx. That's kind of what we're doing. So we're using W of 25, but we're not going to do W of 0. We need to do W of 20. And the reason we need to do W of 20 is because that's when this starts, right? It only works for 20 to 25. So W of 20 plus the integral from 20 to 25 of W prime of t dt. So you're just going to type this into your calculator. You're going to type in 71 plus the integral from 20 to 25 of that formula. I'm not going to show that. We've done it so many times on our calculator. And you should end up with about 73.043. And our units would stay as degrees Fahrenheit because this is a W. Next up, we have another particle question. And we're given V of t. This is a non-calculator question. So for A, it says when is the particle moving to the left? We're going to take V of t, right? Moving to the left means when v is less than 0. We're going to set it equal to 0. And I think actually we did this question in the last video. I'm like 99% sure that we did this question in the last video. But we'll do it really quickly. So we're going to do the inverse cosine. We might have done part of this question, not all of it. I don't fully remember. So we'll do the inverse cosine, the inverse cosine. That gives us pi over 6t is equal to, now, inverse cosine of 0. We get cosine is equal to 0 at pi over 2 or at 3 pi over 2. So what we're going to do is we're going to multiply 6 to all of our answers and divide by pi. And so that gives us t is equal to 6 over 2 is 3 or 9. So those are the times. Oh, sorry, these are our zeros. Right now we need to do kind of a number line analysis on this. And so we're going to do v between 0 and 12. And we have 3 and 6. So I plugged in 1 because if I plug in 1 to cosine pi over 6t, it's just cosine of pi over 6. That's in the first quadrant. And I'm going to think like all students take calculus. In that first quadrant, everything is positive. So I know it's positive. I don't care what the answer is, it's positive. Then it's cosine, they always flip. So increasing, decreasing, increasing. So the particle is moving left for 3 to 6. And because v of t is less than 0. Right, for b, write but don't evaluate an expression for the total distance. So we'll just say our total distance will equal the integral from 0 to 6 of the absolute value of v of t dt. C says find the acceleration of the particle, and is the speed increasing, decreasing, or neither at time 4. So the acceleration of the particle would be the the derivative. Derivative cosine is negative sine pi over 6t, and times chain rule pi over 6. So we need to do v, we want to know is our particle increasing or decreasing at 4. So v of 4 would be cosine of 4 pi over 6t. Sorry, I already plugged in t. 4 pi over 6, which is cosine of 2 pi over 3. 2 pi over 3 is in this quadrant, the second quadrant, right? Because it's 1 less than the denominator. So cosine is negative. And then for pi over 3, we get 1/2. So v of 4 is less than 0. Okay, next we're going to do a of 4. So a of 4, I'm going to bring the pi over 6 to the front. So negative pi over 6 sine of, we plug in 4, pi times 4 is 4 pi over 6. Okay, that's negative pi over 6 times, now sine of 4 pi over 6 is the same thing, sine of 2 pi over 3. And 2 pi over 3 again is in the sine quadrant, the second quadrant, so it's positive, but that means it's negative pi over 6 times positive square root of 3 over 2, which again is less than 0. So that means the speed of our particle is increasing. At time 4, we always want to have the at, because v of 4 is less than 0 and a of 4 is less than 0. If you want to say they have the same signs, that's great. Yeah. And lastly, we're asked to find the position of the particle at time 4. So to get our position, right, that's going to be x of 4 is equal to x of 0, because they gave us 0 in the stem of the question. They gave us the position at time 0 was negative 2, plus the integral from 0 to 4 of cosine of pi over 6t dt. Now this will not be on the test. This integral is kind of hard to do by hand, and we haven't learned it yet. Next semester we're going to learn a method to do these integrals much easier. But remember, the integral of cosine is sine. So sine of pi over 6t. But the issue is, think backwards. If I did the derivative of sine over pi over 6t, we would need to multiply times pi over 6. So kind of backwards would mean that this needs to have a 6 over pi in front, so that when we do the chain rule like times pi over 6, they cancel. If that confused the heck out of you, don't worry about it. It's not on your exam. It's not on your final. We're going to learn a really much easier way to do that next semester called U substitution, which we haven't done yet. So don't even worry about part D. Okay, when you plug all this in, you end up with something like -2 plus 3 square root of 3 over pi. But don't really worry about it. If you got to this point, you're great. Okay, that's kind of what I need you to be able to do. Okay, next one, another particle question. Is the speed increasing or decreasing? This is a question 1, so we get to use a calculator. So on A, we're going to do V of 5.5, and we're going to do A of 5.5. I believe we also already did this part yesterday, so really quickly, V of 5.5 is -0.43534, which is less than 0, and A of 5.5 is -1.3585. You're just typing those into your calculator, right? This at time 4, or 5.5, this at time 5.5. Okay, so that means the speed is increasing at, we always want the at time equals 5.5, because V of 5.5 is less than 0, and A of 5.5 is less than 0. You can say same sign is great. Okay. B asks us to find the average velocity. So we have velocity, so we're going to do 1 over 6 minus 0, integral from 0 to 6 of v of t dt. That's all you have to write on your paper. Then you're going to type in this integral into your calculator. I'm not going to go over that because we've done it so many times. You get 1.949. Okay, C asks for the total distance. Again, total distance, that formula is the integral from 0 to 6 of the absolute value of v of t dt. Again, we've done this so many times on our calculator. You just plug that in. You should get 12.573. And D says for 0 to 6, the particle changes directions once and find the position at that time. So the particle is going to change positions when v of t equals 0. So on our calculator, we're going to need to do the solve button. Okay, and so when you do the solve button, you'll do the solve button of 2 sine of e to the t over 4 plus 1 at 0 less than t less than 6. If that doesn't work, you can also use the graph, right? Graph that and use the 0. Okay, so once you do that on your calculator, you should get t equals to 5.1519. Right, this video is already getting long and we still have a few questions, so I'm not going to show that on our calculator. Right, and so now we kind of want to do that formula of like the whole x of b equals x of a, right, where 5.195 is going to be our b. Right, x of a, we were given the position x of 0 was 2, so we're going to use x of 0 plus the integral from 0 to 2 of v of t dt. Right, that's just that FTC. So we're going to say that this is 2 plus the integral from 0 to 2 of v of t. Type that into your calculator, and you'll end up with something around 14.134. Okay, next one, another table question. And for this one, I'm really only going to go over D. Okay, I did give you guys the answer keys for A, B, and C. Right, and A is really easy. A is, that f of b minus f of a over b minus a. B, we've done a lot. That's, doing a Riemann sum with a trapezoid. And then this would be an average because it's 1/10. So it would be the average temperature of the teapot. And C is the one that we just did, which is that whole like integral from 0 to 10 of h prime of t is h of 10 minus h of 0. Right? The units are going to be the same as the h's. And the meaning is going to be that that's the change in the temperature between 0 and 10. So these three should be easy enough. You have the answers in the PDF, so just look there for the answers. D is the one I want to go over here. So this says at time t equals 0, biscuits with temperature of 100 degrees were removed from the oven. And then the temperature of those biscuits is given by this function b prime of t. And using this model, how much cooler are the biscuits than the tea? And this is a little bit tricky. So we want to, at time 10, right? So first we need to find the temperature of the biscuits at 10. So that's going to be b of 10 equals b of 0. And then because they're cooling, this is a little bit weird, but normally we would want to say like minus, but this already has the negative. So it's a little bit weird is because it doesn't say that the biscuits, if it said the biscuits are cooling, we would have put minus, but it just says the temperature of the biscuits is modeled by this function, b prime. So this is going to be plus the integral from 0 to 10 of b prime of t dt. Now, if you had accidentally done minus here, and you got a temperature that was greater than 100, just realize, oh crap, like my biscuits are cooling. This should have been a plus. Okay, so you're going to type that into your calculator, right? You're going to do 100 plus this integral. And when you type that into your calculator, you should get 34.1828, and it would be degrees Celsius. And so then we need to compare that because it says how much cooler are the biscuits than the tea. How much, right? So the T at time 10 is 43 degrees, right? So we just subtract them, right? Like H of 10 minus B of 10, right? You don't have to write that. Really what you need to show is that you did 43 minus 34.1878. And so that means that we get 8.81, that's my fault, 8.817. So that's what we get when we do that. So we could just kind of write that out. The biscuits are 8.817 degrees Celsius cooler than the tea. Okay, this was kind of a funky one. All right, next up, I'm going to do kind of the same thing. Okay, A is easy. We've done A a bunch of times, right? E of 7, right, because we're doing approximate for 6. So E of 7 minus E of 5 over 7 minus 5. We've done that. Okay. B is saying use a trapezoidal sum for the integral from 1/8 and then explain the meaning. Again, this is going to be the average of whatever this is, right? So it's the average of, just explain exactly what E of t is, right? So it's the number of entries in the box. So it's the average number of entries in the box between 0 and 8. You do a trapezoidal sum. But then C and D are a little bit trickier, so we'll kind of go over those. Those are the ones I want to look at. So C says at 8 p.m., when volunteers begin to process the entries, they use this function P of t equals t cubed minus 30t squared plus 298t minus 976 hundreds of entries per hour. According to this model, how many entries have not been processed at midnight? Okay, well, what we can kind of do is we can come up with a formula that's basically, we know that at time 8, right, like at t equals 8, we know that there are 2,300 entries, right? Like that's how many we have here, right? And so if we want to have a formula for the amount of entries, basically that's going to be like the amount at time, now we want to know at time 12. So we're going to do the amount at time 12 is equal to the amount at time 8, that's our starting amount, then plus the integral from 8 to 12 of the rate in, minus the integral from 8 to 12 of the rate out. Now, there is no rate in. We're not adding any more entries, right? Like it's done. We're only subtracting entries. So what's going to happen is that A of 12 is going to equal to 23 minus the integral from 8 to 12 of P of t dt. Now, one question that I get a lot is how do I know whether I'm supposed to use 8 and 12 or am I supposed to set 8 to be 0 and use 0 to 4? If they only said 8 p.m. and they said starting at 8 p.m., you set that to 0. But if they say 8 to 12, then you use 8 and 12. Okay, so we would do that and we would get A of 12 equals 7. So it would be 700 entries, right? Because our units were hundreds of entries. Okay, and then according to the model, at what times were the entries being processed the most quickly? This is a little bit tricky, but most quickly, right, would be like a maximum, right? And it's actually the absolute maximum. So what we're going to do here is we're going to take P prime, right? Because absolute max, we always take the derivative, set it equal to 0. On your calculator, you're just going to do the solve button, right? Like solve this whole equation equal to 0, comma 8 less than t less than 12. Yeah, I did put calculator there, good. And so we do that and we get t equals to 9.1835 or 10.8165. And so we want to know the very absolute max, right? Because if it's on an interval, like between 8 and 12, we need to do the absolute max. So we're going to do the integral from t, and then here it would be P of t. And we're going to do 8 is our first endpoint. Then 9.1835 is our first critical point, 10.8165. and then 12 is our ending position. And so we're literally given the formula for PFT. So literally these are so easy. You just plug them into the calculator. You just do this at time 0, this, or at this at time 8, this at time 9.1, at time 10.8, and at time 12. So this is 5.0887. This is 2.9113, and this is 8. And so the entries are being processed the most quickly at 8, right? That's our maximum. So entries processed most quickly at at time 12, right? Where, it's 800 entries per hour. D was really confusing. If you messed up on D, don't really worry about it. If you're like, I still don't get it. If you got A, B, and C right, that's our goal, right? D's are kind of like our icing on the cake. They're like our bonuses. Okay, so this one's a rate. How many cubic feet of rainwater just flow into the pipe? I want to talk about that. Just going into. We don't care about the rate out. We don't care about our initial. We just want the amount that went in. So for A, that's just the integral from 0 to 8 of the rate in this case is R of t. Right, so you're just going to write that. Make sure you write that down so that they know where you got your answer from. And you should get something around 76.570. For B, is the amount of water in the pipe increasing or decreasing? So this is, increasing or decreasing amount of water. We need to do the total rate, and we need to plug in 3. So what's our total rate? Our total rate is the rate in minus the rate out. So the total rate at time 3 would be R of 3 minus D of 3. You just type in both into your calculator. You do 20 sine t squared at time 3, and then this whole D equation at time 3. And we're going to end up with negative 0.3136, which is less than 0. So we can say the amount of water in the pipe is decreasing at time 3 because R of 3 minus D of 3 is less than 0. Okay, it's very similar to because F prime is less than 0, but the F prime is the rate, is R of t minus D of 3. Okay, C says at this time, when is the pipe in a minimum, right? Minimum, we have an interval, that's absolute minimum. So the rate questions, the minimums are pretty much always absolute minimums. So we're going to do the rate, R of t minus D of t. We're going to set that equal to 0. So on your calculator, you can do the solve button, and you can just do 20 sine of t squared over 35 minus, and then put in a big parentheses, all of that D of t, and then set that equal to 0, and then at 0 less than t less than 8. And you should end up with, they might give you the answer 0, but that's an endpoint, and then you get 3.27166, I think, or 7. Okay, and then you also could have done that on the graph, right? Like you could have typed that whole thing into the graph and done the 0 button, right? And we want t, and then we want back to the amount. So I'm just going to put amount. All right, so we're going to have 0, 3.2717, and then 8. 0 they gave to us. They said in the question that at time 0, there were 30 cubic feet. So we know 30. For the other ones, right, we're going to say that the amount at 3.2717 is equal to 30, our starting amount, plus the integral from 0 to 3.2717 of the rate in, which is R of t, minus the integral from 0 to 3.271 of the rate out, which is D of t. I know this question is this video is really long, so that's why I'm not showing what I typed into my calculator. I'm just kind of telling you what to write down and what you would type into your calculator. But if you need help typing these in, or you want to see it, just send me an email, say, hey, Mr. Ewert, can you show me the picture of part C on the calculator, or parts B and C on the calculator for this question, and I can go ahead and do that for you. So when you do that, you get 27.9646. Then we would do the same thing for A of 8. A of 8 would be 30 plus the integral from 0 to 8 of R of t minus the integral from 0 to 8 of D of t. You'll do that on our calculator, and you'll get 48.5437. And so the max amount of water, or sorry, the minimum amount of water is 27. I always do both. I always say what it is. So 27.9646, and it was in cubic feet or feet cubed at time equals 3.2717. Okay, and then D says that the pipe can hold 50 cubic feet of water before it overflows. And at time 8, water continues to go in and out of the pipe at the rate until it overflows. And then we want to write but don't evaluate an equation for when that happens. So basically, what happens here is that we're going to have like some A of some new time, and they wanted to call that time W. So A of W will be equal to A at 8, right? Because that's when we're starting, plus the integral from 8 to W of R of T minus the integral from 8 to W of D of T, right? So that's our formula, right? I'll try to clean this up. So A of W, they said, is 50. That's when it overflows. So 50 is equal to A of 8. We just solved for, and we ended up with 48 point, I think it was 5437. Then plus the integral from A to W of R of T dt minus the integral from A to W of D of T dt. Now, because it says greater than 8, I can't fit the dt there, but make sure you have the dt there. Let's see if I can do it. dt, yeah. So because it says 8, I would definitely do it this way. I would do like A of W and starting at 8. Technically, what happens is that since it's the same rate after 8 as it was starting at 0, you could have made this guy 30 and made these two be 0 because it's the same rate, and that's what the answer key showed. But this would also be full credit, and this is probably how I would have done it, because as soon as they say for time 8, I just kind of start there. Okay, and then we're finally on to our last question. Again, we've done so many of these that I'm going to skip through A. A is just the whole, basically V of 24 minus V of 20 over 24 minus 20. And then B is explain the meaning of this definite integral. This is our total distance formula. So the meaning would be it's the total distance that Johanna jogged. And then, I will do this one because this one is different. We haven't done a Riemann sum with an absolute value. So the meaning is I'm not going to go over the meaning. You can write it out. It's the total distance that Johanna jogs in meters between 0 and 40 minutes. Okay, but to do the approximation, right, the integral from 0 to 40 of the absolute value of V of t dt, we're going to just do a regular right-hand sum, except what we're going to do is everything has to be positive. So that's 12, that's 8, that's 4, and that's 16. So we're going to do our right values, but we're just going to turn them all positive. We're going to do 12 times 200 plus, and then it will be 8 times 240. And then it will be, we said it was 4. Now, this is where we do times positive 220. Even though it says negative 220, it's going to turn positive because we're doing the absolute values. And then plus 16 times 150. Okay, and this is non-calculator, so honestly, I would just leave this. I would just say that meters. I wouldn't even try to add them all up. Now, if you do add them all up, you'll get 7,600. It's actually pretty easy math, but I wouldn't waste my time. Okay, C now has a new person, Bob, and it says now Bob is going at a velocity of B of t equals t cubed. They like to do this. They like to give you like one equation and the table, or a table and something else to kind of like compare it and see that you can do both. So they say Bob's velocity is here. What's Bob's acceleration at time 5? So his acceleration would be B prime of t is 3t squared minus 12t. So that means B prime of 5. His acceleration would be 3 times 5 squared is 25 times 3 is 75. Minus 12 times 5 is 60. So it would be Bob's acceleration would be 15. meters per minute squared, right? Because it's meters per minute. When we take the derivative, it becomes per minute squared. Okay? And based on this model, find Bob's average velocity. So for average velocity, we go to his velocity formula, right? And so Bob's average velocity would be 1 over 10. It's from 0 to 10. So 1 over 10 minus 0, integral from 0 to 10 of that formula, t cubed minus 6t squared plus 300 dt. And this is just an integral that we can do by hand. So 1/10 times t to the 4th over 4 minus 6t squared over 2 is 3t squared cubed. Right, 6t cubed. Oh, that's my fault. 6t cubed over 3 will be 2t cubed. And then the integral of 300 will be plus 300t. And we're going from 0 to 10. Now, we do need to plug in, but we don't need to simplify. So I'm going to do this. 1/10 times the integral of 10 to the 4th will be 10 with 4 zeros over 4 minus 2 times 10 cubed will be 1 with 3 zeros. And plus 300 times 10 will be 3,000. Then minus 0. And you can literally just leave your answer like that, but we do need our units, and our units will be meters per minute. So that's how I would answer. I would literally make that my answer. Now, if you want to, right, like 100 divided by 4 is 250. So this would be 1/10 times 250, or sorry, that part's 25. Sorry, 100 divided by 4 is 25, so this would be 2,500 minus 2,000 plus 3,000. And you could do that, and then you could add those up, and then you could divide by 10, right? Like dividing by 10 would chop off 1 0 from each of them. So you could do it, but I wouldn't. But if you did do it, you would get 350 meters per minute. Okay, so I know super long video. This one was about an hour long, but I really did want to go through some of these with you guys, kind of showing my thought process as I did it, instead of just showing you the final answer, because I think that's important as well. So good luck studying, good luck on your practice finals, and let me know if you have any questions or if you need to see any of the calculator work.